So, what is operations research? Some of you may be familiar with it. Excuse me, another student. Um, it's a it's a scientific and mathematical approach to decision making, um, which results ideally. What we want is to have the best design for a system. However, you may define that for your given application, whatever best means for you or for the people you're contracting for, um, we want to be able to qualify that and to qualify all the decisions we could make, and in fact quantify all of that to compare different solutions and find the best one. So this class is called deterministic operations research. Deterministic here just means that um, all of our parameters of any given problem are known with certainty. Um, there's other fields of operations research, stochastic optimization, where there's a probability associated with certain things in the objective function or in um, other parts of the problem. We're not going to be looking at that. There are whole classes dedicated to that topic. First, we're going to deal with when we know everything with certainty, and in fact, when our problems can be modeled as lines, groups of lines, linear functions. We'll talk more about that, but that's the gist, the scope of the class. Right. So, mathematical optimization, operations research, used for all sorts of things. Um, some of the classic problems are in the fields of production planning, facility location, and network design. This is a slide from Inform's website. Inform's, the OR there stands for Operations Research. It's a group of OR, management science, information science, um, just a group. Probably the biggest OR related group in the world, but they have all of these different applications they point out. Um, one of my colleagues, another student of Dr. Hildebrand, recently did his he defended his dissertation, his PhD dissertation, on optimizing the motion of robots, specifically these little assembler doohickeys that I don't really understand. But if that's something that interests you, we're using operations research in that field. Specifically, he was talking about using the robots to construct things on other planets. My field, the field that I've been studying, is redistricting. So here's a map of the voting districts for, I believe, the congressional seats in Virginia. That might not be true. This might be, I don't remember. This is an old figure. But our aim is to balance representation between um, black and white voters, Republican and Democrat voters, what have you. We want to make sure that everyone's vote matters, or at least matters as much as anyone else's. So a few other things to rattle off: manufacturing, logistics companies, service providers, government, military, biology and healthcare, economics, business, the business schools. So OR in a lot of schools is in engineering, as it is here. In a lot of schools it's in math, as it was where I came from, and it's in there at Clemson. In a lot of schools, notably Carnegie Mellon, many others, it's in the business department. So this is really a very multidisciplinary field, and you can apply it to a lot of different things. Here's another informed slide. Sorry that this is a little pixelated, but I just screen captured this from the website instead of typing it up again. We're going to talk about the syllabus briefly. I've talked about what OR is. That's my email, which you all should have seen by now. Lectures. You guys have found the lectures. It's at that Zoom link. That's on the Canvas site, obviously. Office hours. I haven't scheduled regular office hours yet, but I do want to do some tomorrow. 4 to 5. 4 to, let's make it 6. That's the wrong one. 4 to 6 Eastern. That'll be July 7th. In case you want a refresher on linear algebra, anything else we talk about. I'll try to figure out, well, I'll figure out my regular office hours before next week. And I'll try to be adaptable and have office hours that everyone can get to. And I'll definitely be open to setting up times outside of my regular office hours. So if they don't work for you, email me or get in touch with me however, and we can set up a time. Some important dates. Classes begin today. The add deadline is, I guess that's Friday. Drop deadline is the 19th. Blah, blah, blah. There won't be any class on the weekend of July 29th to August 1st. I'll be out of town. And the last day of class is August 12th. The books that will be, well, the book we will be using is this. I do expect you guys to read the book. It's very short, and I think very legible. At least we're only going to be using the first third half of the book. You can pick it up at either of those two links. I did have one student has contacted me and said that they had trouble getting a hold of it because they were not in the US. If that's the case, please let me know, because I want to encourage you all to read. If there's any major failing of my undergraduate education, is it fine if my textbooks arrive on Friday? Yes, absolutely. I have some reading quizzes posted already. Those two will not count towards your grade. They're just to give you an idea of what I expect from your reading quizzes. They're really short. As long as you read the chapter, they're really easy. But the two this week will not contribute to your grade. And we'll talk a little more about that shortly. I really enjoyed this book when I learned from it as an undergrad. I hope you guys do too. Moving on, I have a few more books that I want to recommend that are not required. This one, there's a GitHub link to an open source book that my advisor, is there an online version, if that's okay with me? There are ebook versions. I believe Amazon has one. Google eBooks has one. I found one on Kobo. That's the one I recommended to our classmate who is abroad. If you have trouble finding one, get in touch with me. But I don't have any qualms with you using a electronic format of the book. I've tried to. I don't think there are multiple versions of this. I believe there's only one version, so it shouldn't be a problem. So yeah, this open source book, my advisor is working on it. I'm helping him out a little bit. Some of our class notes will be imported into that book. I've left the GitHub link to the PDF of it here. It's a good resource. It's still a work in progress, and it's not particularly complete yet. But if you want to take a look at it, please do. These two other books. This first book is the book that has traditionally been used for this class. It is out of print or for some reason difficult to get, so I was encouraged to use a different book because they're awfully expensive at the moment. This last book is the graduate level book for this course. If for some reason you're like me and you're interested in the mathematical theory and the proofs and stuff for anything we talk about, this book is the de facto resource for all that. Yeah. So what will we be doing in this class? This comes from the syllabus that I was sent. This is what you were expected to know by the school. You're going to be able to formulate linear programs and network models that are deterministic and that apply to a variety of contexts. You're going to be able to optimize on those LP and network models. You're going to be able to identify redundant constraints and feasible solution spaces, etc. Identify technical issues regarding LP models and how we solve them. Implement algorithms to solve LPs. LPs here meaning linear programs. Solve LP or network problems using modeling languages and optimization softwares. That'll be a big part of this class, is software. Analyze problem solutions using duality and sensitivity analysis, both major topics we'll talk about. Use duality theory, and finally to be able to communicate the above material effectively in a written report. And additionally, that written report is supposed to be a group project. Moving on, there's on the Canvas site, there's a little tab called Piazza. It's basically a forum where we can post questions and get answers from me, from the TA, from other classmates. If you're not signed up, there's a link on the syllabus. You should already be in their system because you're on the Canvas site, but if not, there's a link for that. Prerequisites: you're all expected to have gotten a C- or better in linear algebra. The main thing we'll be taking from linear algebra is row reduction and matrix multiplication, and just general use of matrices. The two other fields that we'll be dabbling in are graph theory, which you'll be a little familiar with if you've taken any computer science in the past, and calculus. We'll use very little calculus. I don't know, I'm not positive that you guys will ever be required to take a derivative or anything, but I will occasionally use calculus to demonstrate things in class. Graph theory, if you don't know what that is, what that means, don't worry. That I'll explain that thoroughly when we get to those topics. Grading policies, I've talked about the reading quizzes that I'll be posting. You'll have homeworks. You'll have a group project that you'll have to do, an early intermediate draft, and a final project that'll be due the last day of class. And there's my grading scale, pretty standard. Reading quizzes. Well, before I talk about that, this is a summer course. So instead of, 16 weeks that a regular semester has, we have 6 weeks. And we have to cover the same amount of material and with about the same amount of graded content. So it's going to feel like there's a lot of assignments. And that's just the nature of how a summer class has to be, because we have to move quickly. We're lecturing every day, so instead of having one homework a week, maybe two. On average, you should expect to have 7 homeworks total. That's what I have on the schedule. And expect to take 2 to 3 reading quizzes every week. But those will be very short and very easy as long as you've read the material. Reports, so that'll be with respect to your project. You're going to work in groups, you're going to gather some data, you're going to model it, you're going to implement and solve it, interpret it. For some large-scale application problem, I have not yet decided the exact specifics of that problem, but I'll let you know as soon as possible. If you have a particular application that you're interested in, let me know. If there's something you want to do a project on, let me know, and we may be able to come to an agreement. Let you do something a little bit different. Late work. I've made the decision to accept late work with a penalty. That penalty will be up to me, probably 10 or 15 points off every day. We do have people that are in different time zones, and in fact different dates. So if that becomes confusing to you, let me know. So if assignment due dates are problematic because of you're across the date line or you're in a different time zone or whatever, let me know. Or if you're sick or you have other obligations, or if it's just a tough assignment and you're not making any progress, let me know, and I'll be more lenient. Regrading. There's a regrade request on Canvas. I don't think I've actually uploaded that yet. Let me make a note of that. Yeah. So you may have seen the schedule that's on the syllabus. This is my first time teaching a full course. I've given several lectures, but I've never had to plan and time out and schedule a full course before. So what I was encouraged to do was have an explicit schedule, but schedule plenty of time to make up for days we go over and can't complete what we want to do if we get behind, and also to answer questions from students. So I've scheduled every week a question/catch-up day, which will be used to answer questions that you guys have, go over extra examples, or if we get behind, to make up some time. Yeah, if you have questions, as I mentioned before, try to submit them on Piazza, that forum on Canvas. I think that'll be a pretty useful tool if we're all plugged into that. Absences. Absences will not be tracked, nor will they contribute to your grade. We will do some in-class exercises in groups. But if again we have people in different time zones, it may be difficult for you to attend, so attendance is not required in any way. Recording class. When should we expect the lectures to be uploaded onto Canvas, and where can we find them? I will have a folder in the file section for those. Recorded lectures, I assume you're talking about. I already have the slides uploaded. I will be marking on slides, so I will upload annotated slides immediately after I give the lecture. I'm not sure how long it will take to actually upload the videos, the recordings of the lectures, but I would hope it's by a few hours after class. I'll let you know if it's taking longer than I expect. The department encouraged me to record lectures, and also, again, we have people that might find it difficult to attend at the scheduled time. I recommend attending the live lecture if you can. It would make me happy, and I think you'll get a little more out of it. Here's the schedule that I have written up. This version is actually a little outdated, but you can see the updated one on Canvas. You'll notice I have 7 homeworks scheduled. I will never move a due date for a homework backwards. I will push them back, but I will never move them closer. So if we're having trouble on a specific assignment, let me know. If enough people are having issues with it, we'll push it back. And but I will never, no matter how fast we're moving through the class, I will never pull them forward, make them do earlier, sooner. Is there a printable version of the schedule? I will make one available. I think that's what I want to talk about on the schedule. I have your reading assignments there. Those may move around if lecture topics end up moving around, taking more time or less time. Your readings may move. And I've tried to label them by section rather than page because I know some people want to use ebooks, which may not have the same numbering scheme. Anyway, to say it again, this is my first time teaching a full course. I will appreciate feedback. This is something I want to be good at. I've done a lot of tutoring, and I've done individual lectures to undergraduates, and I've always enjoyed it, and I want to be good at it. So if you're having any problems with the course, or if you just want have a suggestion or anything, there's a Google form, which again I'm not sure I actually uploaded. But I'll make that available. Please fill it out if you have any suggestions or issues. Secondly, I mentioned my background is in mathematics, and that I enjoy the theory of mathematics, of operations research. I enjoy the math behind it, maybe even more than its application. And I do have a tendency to focus on that aspect. So I'll do my best to ground everything in applications using example problems and whatnot. But if you think that I'm getting bogged down in some theory, or you just want better justification for why I'm doing something, please speak up, because I don't want to give you something. I don't want to teach something that you're not going to get anything out of. Accommodations. Any student who thinks they need, feels they need, or knows they need accommodations because of a disability, contact me as soon as possible. Get in touch with the SSD office, and make sure that I get some SSD documentation about that. Honor code statement, you guys have seen this, and the principles of community statement. We all want to be inclusive, and we want to be accessible. So if I'm doing something that offends your sensibilities, please let me know. Are there any other questions? People have typed some in the chat that I've answered. Feel free to speak up. It would make me happy if you would turn your cameras on, but I'm not allowed to actually require that. But I'll sit here for a little bit. Are there any other questions?
For the readings, do you want them done before the lecture of that day or like after?
Before is before, ideally. Yes, before. If you don't get around to it, so the reading quizzes, you'll have a lot of them, and they're not really worth that much. If you don't get around to it, it's not a huge deal. 1 or 2 days. But I would encourage you to read if you fail to make it before the lecture. Read it anyway. That's my recommendation.
Is there any of the software that we need to be downloading for this class?
That's an excellent question that I, for some reason, didn't discuss. So the two softwares we'll be using are Excel Solver, and Python. Excel is nice because we can format our we can format things to look like how they look on the page when we write them, at least to a sort of respect. Python is nice because it's much more powerful and allows a lot more variables, a lot more plugins and things. So if you're familiar with Python, great. If you're not, we'll try to do a recitation section and get you caught up on the basics and get that installed. Is there any good way to prepare for class? Specific IDE will be using Python. Preparing for class, the reading, preparing for the class in general. Brush up on matrix manipulations, row operations, row reduced form, that kind of thing. The specific solver we'll be plugging Python, we'll be using with Python is called Pulp. So that doesn't require a license or anything, unlike some of the more powerful commercial solvers. And we'll talk about that at some point when we get around to it. It's on the schedule. I do want to, so we've got plenty of time left. I want to, if we're done with questions about the syllabus, about the way the class is going to look, I want to move on to just showing some of the optimization problems that you've done before and try to recontextualize them in sort of the parlance of linear programming. Whoops, we're on the wrong page.
I had 2 more questions
Sure.
if you're available.
Yeah, absolutely.
So the first one, I noticed that the homework 1 modeling, like obviously I was just trying to click it to like see what it was going to look like, but when you click it, nothing happens.
On the schedule or on
no, like
the
actually
assignment site?
on the homework and like the assignments.
Huh. Okay. I'll investigate that.
Yeah, it doesn't work. I just had to go to the files and find the homework there.
Yeah, so it is uploaded in the files section. I'll look at the link.
And
Try to get
my
that
other
working.
question was, will we be using any type of like lockdown browser for like tests? The reason I'm asking is because I do all my notes on my computer, and I know like some professors will say that they're going to use a lockdown, but then they'll say that it's open notes, and I'm like, I can't see my notes.
Right. Um, I am not planning to do any tests for that exact reason. I'm new to this. I don't want to step on any toes with lockdown browsers. I want to make this as simple for everyone as possible and as accessible. So I won't be doing any tests. So no lockdown browser. But you bring up a good point. Homeworks. Um, Feel free to collaborate on whatever. Turn in your own work. Write it up yourself. But feel free to ask questions to people in person. Feel free to ask questions on Piazza. Um, in fact, I would encourage you to ask your questions on Piazza so that everyone can see them. On Piazza, don't post the answer, the solution to the problem, would be my one qualm about that. But feel free to collaborate on things. Does that answer your question?
Yes.
Great. Great. Anything else? Cool. So let's get into it. Start with a little bit of linear algebra. Let me turn on my notes here. You guys have all taken linear algebra. It's a prereq for the course. So, hold on. My pen's not working. Give me 2 seconds. Great. So, maybe the way you think to solve this system of linear equations is to go straight for... Huh. That's weird. There we go. We're back in action. So maybe the way you think to do this is to put this in an augmented matrix. And that's exactly what we are going to be doing. This is the primary thing you need to remember from linear algebra. If you don't, please let me know, and I'll be happy to set up a recitation session to discuss what this is, what it means, how it's done, anything like that. We will be doing row reduction in this class, if you remember that. We won't be doing a ton of it, but it is an important aspect for how some of these problems are solved. So if you're not familiar with row reduction, I get the Gauss-Jordan method, let me know. So just to be quick about this, I'm going to combine a few row operations into one step. And show you what you ought to have learned in linear algebra about how to solve these things. So, systems of linear equations. The idea is that these equations tell us what solutions are possible for a given word problem. And the de facto way to solve these is to perform row operations on the augmented matrix, which means just the matrix of the coefficients augmented with an extra column. That's the right-hand side of all the equations. Row reduce it until, nope, that's the wrong one. We get to an identity matrix on the left-hand side. And that tells us, let me put the row operation in. Row 1 minus row 3, row 2 plus row 3. That tells us that for this system of equations, and for whatever real-world made-up word problem we have, that this system corresponds to or represents, this is the only solution to that problem that's feasible. So we call this a feasible solution. In this case, it's the only feasible solution. Because it's the only solution that satisfies all of those equations. In this class, in the parlance of operations research, we'll call these constraints. That's just going to be the set of all the equations or inequalities that are telling us what solutions are feasible. What if we have the same system here, but with just a new column? Just to be quick about it, performing exactly the same row operations gives this augmented matrix. Oh, we've got a few people. This, we have our identity here, so it's in row reduced echelon form, but we have kind of a spare variable here. So we get that x, y, and z plus w times clearly if we let w equal 0, we have the same solution as before. That same solution is still feasible. But w can be any real number. So here we actually have I'm writing on a drawing board, so my handwriting may not be flawless. And also my spelling is atrocious. So I'm just going to not even try to spell infinite. Infinite feasible solutions.
Where are you getting the 6 and -3 and -4? Like, is that just from other steps from beforehand?
Yes. So I did exactly the same row operations that I did on the previous slide to the augmented form of this matrix of that system, and that's what I got. Could be that I'm wrong, but I did it a couple times, so I hope I'm right. We call the set of feasible solutions the feasible region. So here, in the previous problem, our feasible region was one solution. In this problem, it's a line, a one-dimensional line in a four-dimensional space. In the problems that we'll be working on later, it may have the feasible region may be n-dimensional. We'll start with 2 or 3 dimensions, but dimensions here just means the number of variables that are free. So we've talked about constraints, we've talked about feasible solutions, feasible regions. Let's pivot a little bit and think about this problem from physics. If you've taken Physics 101, you've probably seen this problem. So the height, so a ball is thrown upward with a certain velocity. We're going to ignore air resistance. What's its maximum displacement, or since it's thrown upward, height? Is given by this equation. Starting, if we call at rest 0, it has 20 meters per second upwards minus 1/2. I'm just going to approximate g as 10. 10 being g, or g being the acceleration due to gravity. We want to find its maximum height. In calculus, we learned how to do this. We just take the derivative with respect to time. We set it equal to 0. Derivative of this is 20 minus 10t star. And here I'm just using star to represent that if this equation is satisfied, t star is our optimal solution. Solving this for t star, we get that t star equals 20. Is that right? Nope. No. I'm looking too far ahead in my notes. T star equals 2. I keep pressing the wrong button. Then, what we wanted was the maximum displacement, the maximum height. So we're going to have to plug t star back into our initial function. 20 times 2 minus 1/2, 10 times 2 squared, 40 minus 20, 20. 20 is the maximum height. So our objective in this problem was to maximize the function y of t. So we call y of t the objective function. Is that behind my head? That is behind my head. Let me grab that. So those are two of the most important words you'll have to know for this class: constraints and objective function. So for any problem we're solving, we want to know what solutions can we have that will work, what feasible solutions are there, what's the feasible region, and thus we want to know first, what are the constraints on the problem? What are the equations that define the feasible region? It's the first thing you want to pull out of any word problem. Well, one of the first things. The second thing we want to know is which of those solutions is the best one. And however we define best in a given problem is our objective function. And so you want to pick that out early in the process. That's part of modeling, which is what we'll talk about. Be the first topic we really talk about in this class. So let's do a problem real quick that has both an objective function and a constraint. So, and I'll write it in sort of the format that we'll be using forever. You've probably seen this problem, maybe exactly, in a calculus class. A farmer has 800 feet of fence, and he wants to enclose a rectangular field with it. One side of the fence is already accounted for by a natural berm. What side lengths will produce the field with the biggest area? So what's our objective here? We want a biggest area. Biggest is going to mean maximize. The two kind of senses that we're going to do this in are maximize and minimize, which means there should be an E here. We want to maximize area, which it's a rectangle, so length times width. That's our objective. And it is subject to a constraint, right? The perimeter of the three sides can't be any bigger than 800 feet because that's as much fence as our farmer has. So the perimeter length plus 2 times the width equals 800. Now maybe later in the class we'll see that the farmer has 800 feet of fencing, but he doesn't necessarily have to use all of it. So maybe the more proper thing to do would be to make that an inequality. He could use as much as 800 feet. At this point, we don't know how to deal with that yet. So we're going to leave it as an equality because that's going to be the best solution anyway. So this is our constraint. We do know how to solve this problem by substitution and with a little help from calculus. We're just going to solve for length. Solve for length, plug it into the area. Yeah. And then take the derivative with respect to our variable width. E. 800 minus 4W equals 0. This gives us that, where's my head? So that gives us W equals 200 feet. Plug that back into length equation. 800 minus 2 times 200 is 400 feet. And then the area is 200 times 400 is 8,000 square feet. So you should all be familiar with problems like this. I don't know how far back you all took calculus, but you've seen something like this before. This is a nice example of an optimization problem that has an objective and it has a constraint. And so it looks sort of like the problems we're going to be solving in this class. However, this objective is not linear. It's quadratic. It has two variables multiplied together, which means that it's outside the scope of this class. We solved this using calculus. We solved this from a course we've already taken. In this class, what we will learn in this class will not give us the tools to solve a nonlinear problem. But I thought it was a nice example of sort of the basic process. That is all I have prepared for today. And we still have 15 minutes, so I'm just going to say the reading for next class is 1.1 and 1.2. I'll give you some examples of what a linear program is, and then we'll discuss it more. We'll do some more examples tomorrow. Reminder that there are is this lecture being recorded? It is. I'm not recording it through Zoom. I'm recording it off of Zoom through the same program I'm doing the green screen trick with. But I'll remind you that there are reading quizzes posted. They will not. These two will not contribute to your grade, but they are a good example of what I expect to do with the rest of the reading quizzes. If you have the book, I encourage you to read it anyway. If you don't, let me know, and I can post the reading. I can't post the whole book because I don't own the copyright, but I can post a couple chapters. And I can stick around for a little bit if anyone has any questions about anything I've done today, any other linear algebra questions. If you are having trouble remembering your row operations, I can stick around a little while. But other than that, you guys are free to go for today. Thanks for listening. I hope I was a little bit engaging. Have a good one. See you all tomorrow.
Thank you.
No problem.
So I had a quick question, if you don't mind.
Sure.
I know earlier when we were going over the syllabus, you mentioned there were a few, I guess, programs and stuff. You said Python and something with Excel that we would need for this class. Is that going to be released in a list at some point so that we can get those acquired, I guess?
Yes, I can do that.
Okay, thank you.
I have a quick question too.
Absolutely.
So for the reading quizzes, it says unlimited attempts, so we can take it as many times as we need.
Yes, I failed to make that clear in my talk just now, but yes, you can take that as many times as you want.
Okay, and it won't like deduct points or anything?
It shouldn't. If it does, let me know.
Okay, awesome. Thank you.
Thank you, Professor.
No problem. Do you three have any questions? Nope.
I do have a question.
Sure.
It's just something at first. Can you hear me?
Yes. It's not great.
Hello?
Yes.
Yes. It's
Okay.
not great.
Let me try
Yes.
something. Is it better now?
That is better.
Right. Was asking. So my laptop is broken. It broke yesterday. So I'm trying to fix it. So I'll submit today, and I don't know when I will be able to get it back.
Right.
So I will not be able to use Python or Excel till that time.
Right.
Will that be a problem? Because I know this is a summer class, so it's a it's a fast-paced class.
Yeah. No. Well. Yes, but I'm not gonna hold it against you. I'm not gonna penalize you for it. Um, if that makes any sense. The faster you can get it back, the better.
Yes.
I
Yeah.
obviously you know that. Um, but if it's taking more, so there's a, if you see on the schedule,
Yeah.
one of the homeworks says software on it. That's the due date for when you will have to have it. If you don't have it by then, let me know. If you
That
get it
should.
really close to then and you don't have enough time to finish the assignment, let me know, and I will push that back for you as far as you need. Um,
I
but I won't be asking you to do software stuff in class. I'll be presenting it to you.
That's good. That's good. That's
So yeah,
what I was working on.
great.
Thank you very much, Professor. I'll try to fix it as soon as possible, and hopefully to be done by this week. I hope so.
That would be great. But if not, let me know.
I will. Thank you very much.
Sure thing.
That's it for me. Bye.
Bye. Do you have any questions? Nope. All right then. I'm going to go ahead and end the class.